All right, guys, welcome back again. We are now looking at question 4, and the instruction here is for us to simplify the following expressions fully, leaving exponents as positive integers. Okay, let's get right into it. So this one, guys, is what? 5x squared multiplied by 2x squared. How do we go about solving this one? It's actually quite simple and straightforward. You see a multiplication, you know that you are multiplying. It's that obvious, guys. So what we are going to do is start by multiplying the coefficients of our variables, and then after that we'll multiply the variables. So I'll say, what is 5 multiplied by 2? The answer is 10. And then I'll say, what is x squared multiplied by the x squared? I should get x to the power of 4. Why am I getting 4? Because if I'm multiplying two bases that are the same, then the exponents are going to add. Laws of exponents. X to the power of 2 multiplied by x to the power of 2 is equal to x to the power of 2 plus 2, which is equal to x to the power of 4. You don't have to show this. I'm just showing you how the 4 actually came about. Okay, this is your answer. You are done. Remember, you don't have to show this step. That's why it's just 1 mark. Okay, so that's how we answer that question. And then now we go to B. You see, for B, we have the same thing, but addition. So if you see addition, it means the exponents of these two variables are not going to add. Guys, make sure that you are able to distinguish the difference. Okay, if you see the addition, it means you are only adding the coefficients of what? Your like terms. This means that these are like terms. So if it's like terms, we're adding the coefficients only, not the exponents. Okay, so the answer here is simply going to be, what is 5 plus 2? 5 plus 2 is 7. 7 of what? 7 of x squared, because we are adding the two like terms. Does that make sense? All right, let's go to C. For C, what we'll have is multiply this one with this one first, and then the other answer multiplied by this one. So, like I always say, we start with the coefficients first. I'm going to say negative 6 multiplied by 2, and the answer is going to be negative 12. And then I go to the variables now. I say AB multiplied by A squared. What am I going to get? When I multiply A and A squared, I'm getting A cubed B. So when I say AB multiplied by A squared, it means I'm going to get A cubed B. Why am I getting A cubed? Because there's a 1 here. 1 plus this 2 is 3. If I'm multiplying bases that are the same, the exponents should add. The B is not affected. That's why it remains the same. But remember, we still have this multiplication of 3bc. So now we are going to say negative 12 multiplied by, we are going to say negative 12a cubed b multiplied by the 3bc. Okay, here we will use the same approach of starting with the coefficients first and then following up with the variables. So when I say negative 12 multiplied by 3, what am I going to get? A negative 36. Then I say a cubed b multiplied by bc. I'm going to get what? A cubed b squared c. Do you see that? That's how I get my answer. I'm saying a cubed b multiplied by bc. The a cubed will not be affected, so it remains the same. But the b is what? B times b, meaning the exponents are adding. And if the exponents are adding, we know there's a 1 here, there's a 1 here. 1 plus 1 is 2, so we get b squared. The c is by itself, so it doesn't also change. It remains the way it was before. And this becomes your answer. Okay, let's go to this one. I think I need to use another paper for that one. Okay, here we are solving D, and this is how D looks like. If you see division here, it means we are applying law 1, right? I mean law 2 of our laws of exponents. And remember what law 2 says. It says that if I'm dividing two bases that are the same, then the exponents are going to subtract. Okay, so the way in which we are going to solve this one is by saying, remember this, the bases and exponents that are at the top always remain the same. We only bring the exponents that are at the bottom to the top. So I'm going to subtract this exponent from this one, this exponent from this one, meaning that I will write what is at the top as it is, but I'm starting with the tens. So I'll say 10 to the power of 3 and then bring this 5 to the top. If it was positive at the bottom, it will be negative at the top. So it's going to be negative 5, and then I go to the a squared, write it down as it is, take this as exponent to the top, minus 5. Then I proceed, write the base of 10 as it is, and then go to the exponents. What is 3 minus 5? I'm going to get a negative 2. Do you agree? And then I move on to the a, write it down as it is, and then I go to the exponents. What is 2 minus 5? It is negative 3. Do you agree? And then when I proceed, let's go back to the instruction. The instruction said that we have to leave the exponents as positive integers. Here, it is negative integers. We want them to be positive. So what happens is that because I want these to be positive, I'm gonna have a 1 at the top. You remember this law. If I have a to the power of negative 1, my answer becomes 1 over a. Remember this, meaning that I'm making this exponent become positive by taking it down and making it a denominator. So for me to have this exponent become positive, I have to take this base and make it a denominator. So that's what I'm going to do. Here, I will have 10 to the power of 2. Do you see now that this exponent is positive? Then here, I will have a to the power of 3. They are now at the bottom as denominators and are both positive. Then, last but not least, 10 squared can be written as 100. So I have to change that, meaning that my final answer will be 1 over 100 a cubed. That is your final answer. You can